Today I did a little bit of work of securely storing API keys of a third-party service I'm interacting with. I thought I should make a video on this because we're all doing the vibe coding and letting LLMs write a bunch of code for us, and there's all these stories of all these credentials getting leaked and everything that can go wrong, and something that an LLM might just blindly throw plain text into a database and expose it all, right? So let's do a video on a way to securely store something like API keys, use them within your server securely, and just never expose them otherwise. So first things first, this is my account entity. Here we're using type ORM, so you can see type ORM and all the other stuff I'm using. What I'm about to describe, all these ORMs will have similar features. So whatever you're using, you can have a similar feature, or really, if you don't, you can just put this kind of idea at the point where you access your data once and write the code once, and try not to make it to where you have to write this code every time you access the data. So here we can see the meat of what's happening. Type ORM has this transformer attribute on column, the decorator for putting columns on tables. And importantly, transformer does a to and a from. So to is when we save the data, perform this action. From is when we query for the data, do this action. So really simple, we've wrote our own encrypt and decrypt functions to run on the to and from. All right, so let's take a look at what the encrypt does. So basically, encrypt is going to take our string, create an encrypted value, and insert that into our database. So never ever should we log the value that comes in here or expose that value anywhere else in our code. If we want to dive into what encrypt does a little bit and how it works, there's 3 steps to it. The first step is the random initialization step. So this is going to make it to where, say we have the same string twice somehow, it'll result in a different encoding string every time. Next up, we have this authentication tag step, and what this is going to do is give us a little bit of sanity in knowing that nothing has happened to our encoded value from the time we encoded it and stored it and the time that we got it back to decrypt it. So this basically makes it to where the decrypt step does a little bit of validation to make sure what we encrypted never changed. And then the last thing that we do here is put everything together for the decryption step. So we take the IV, the auth tag, and the encrypted value, we separate them by colons, and that way it's formatted to where decrypt can just kind of take this apart with the value that it has. So decrypt is kind of the same thing, but just in the opposite direction. There's no reason to really read this line by line and go over it. It's encryption, but backwards. Okay, so how do we know we're not crazy? We write tests, right? So we have some tests here that basically do some simple things just for the sake of showing in this video, right? Should encrypt and decrypt a value. So we have our fake API key, we encrypt it, we get our encrypted value, and basically, is it the value that we gave it to begin with? And then, should encrypt a value, basically, is the encrypted value different than the value that we encrypted? This is checking our functions to make sure we don't break our API and like rules and returning null. And then we do validate some of the other things like the IV, right? The unique individual value. So we encrypt the same thing twice and make sure the values are different. And then can we also like handle just random characters? So we'll run our test suite. And we're going to run the whole thing because I just forget the command for running just this one test, but you can see here everything passes, right? All right, so now we have our server up, and we're just going to run this value, and we're going to take a peek in our database so that I can show you that it did encode the value. So this is our resolver. This resolver is basically just doing what we described. It's taking in an access token, and it's going to encrypt it and store it on that account entity in the database. So we'll run it. We'll see that it came back happy, success true. So now we just hop over to our database and we're going to look at this column for the access token. Okay, so now we're here in our database. I use dbeaver. We're looking at our accounts table. We have our user that we set this API key for, and we're looking for the Manipool API key column. And you can see here that this is not the value that we sent the server. So we can see that it's successfully encoded it. So that's just really simple node encryption, decryption, and making sure that you're securely storing sensitive values inside your server. I don't know if I talked about it, but you also seed your encryption with a key value, and that's something you'll set in your env level, and it'll be different for all of your different environments, so development, staging, production. And also you can just assign different keys to different encryption services if you want. So like if you want even more security, maybe one key, something gets exposed accidentally and it means all your other data is still fine. So like maybe for my Manipool API key, I use an encryption key, and then I'm going to do things for eBay, and I'm going to do things for TCG Player, and like those might have different keys. So that way it's those vendors will be happy that everything's separated at least. All right, so that's a really simple look at encryption and decryption in the age of AI and LLMs, and something you can do to make sure that your LLMs aren't going nuts and not securing your users' data. So see you next time.